prospective programmers, game designers, and anyone else watching this tutorial. My name is Carlo, otherwise known as Neoxid501, and this tutorial will be about the Godot Game Engine, how to get started on your first game, and generally becoming familiar with what it is. So, it is presumed that before you begin this tutorial that you should already have the Godot engine installed. If you do not, please go to godotengine.org/download, download your respective version of the engine that is needed for your operating system, and then check out export templates as well. Keep that in your downloads folder, we'll reference it when we need to. Additionally, it is recommended that you also check out the Godot docs tutorials because they are very comprehensive and helpful. And for your future reference, check out the Godot API as it includes detailed instructions about how to use each of the various included features as well as nodes in the engine. And we'll get to what those are in a sec. Additionally, you should also have a folder open labeled, well, preferably labeled Godot projects, where you're going to put your Godot project that we're going to be working on, as well as the included Godot workshop zip folder. Included should have been a README as well as a folder with contents that look like this. The four included docs down here are all of the same and are just included in multiple formats to make sure that you can open it. And the Godot Space Shooter includes sprites that we're going to be using to make our game. The .pdn here is for paint.net. You don't necessarily need to use that. You really only need the regular PNGs included. And yes, I drew them, and yes, they're bad. So now, let's get into the actual engine. Go ahead and open the Godot Game Engine. And the first thing you'll be greeted to as soon as it loads is your list of projects, possibly empty if you haven't worked on anything yet, and this general menu scheme. Now, before we actually open up or start rather our new project, I'm going to go over to the Godot projects folder that I mentioned earlier, and I'm going to make a new folder. I'm going to call it Space Shooter 1. I'm calling it 1 because I already have a Space Shooter folder from doing this earlier. So now, go ahead and take your Godot Space Shooter folder that's located in the Godot Workshop included file, and go ahead and just plop that in to the Space Shooter 1 folder. Done. Now, go over to the Godot, back to the Godot engine. Over here on the right-hand side, you're going to hit New Project. Go ahead and browse over to the Godot the Space Shooter 1 folder in Godot Projects. There it is. Double click on it, open it, make sure you see the Godot Space Shooter folder, and hit Open. Automatically labels the file for us, and we can just hit Create. It should appear in the list for you, as well as populate the folder with some important files that the Godot engine needs to actually run. Go ahead and left click on it, on the Space Shooter 1 project. Godot will start up, and you'll be greeted with a fancy 3D working environment. The Godot 3D environment is rather complex, and for the scope of this tutorial, we won't be using it. If you are interested in making a 3D game, I do recommend it as a resource, as well as, of course, looking into other 3D engines such as Unity and Unreal, but Godot is definitely an option. Now let's go over to the 2D screen by hovering over here. And this is our 2D setup, which is much more simpler, and again, for a comprehensive view of what Godot actually is, this will be sufficient for a tutorial, I feel. So let's get introduced to some of the important parts of the engine. Let's start with the actual, what we're looking at. We're looking at a scene. Scenes in Godot contain nodes, and nodes are objects. If you would like, you can refer to as a scene as a window, and a node as just an object if you're more familiar with programming. We put these objects, these nodes, into the window, the scene, and we program the objects with some of the code, with some of the coding language, which would be GDScript in this case, to do things within the window, and hopefully these things translate to the mechanics of a game. So to edit our particular scene, or rather the project settings, go ahead and click Scene in the top left. You can go to Project Settings. These are some general things that if you're going to work on a full-scale game, you probably want to know what a couple of these things are. Mainly display for the width and height of the window. Physics, if you need to lock the FPS for whatever reason. If you're going to use the physics, you can change the gravity values in here as well. And there are some other useful details included in this section. But to start off, as do most Godot projects do, we're going to add a node to the scene. Do so, go ahead and click the plus button under the scene. And specifically, we're going to add, we're going to first expand node 2D, going to expand collision object 2D, then we're going to expand physics body 2D, and we're going to use kinematic body. Double click on it and it'll be added to the scene. Now I'm sure you've noticed, I'm going to click it again here, that there's a lot of nodes. All of these nodes perform a specific function, although they obviously can be modified with GDScript or even modified in Engine with C++ if you're so inclined. There are a lot of them, and most likely if you need something done, there was a node for it and a method that goes along with it. Again, refer to the API if you have a question about what a specific node might do, or maybe if you're just looking for something, it's probably there. Going back to the engine and closing this, let's soft double click onto kinematic body 2D and rename this the player, because this will be our player object. Now, we can't see the player, can we? Let's change that. Go ahead and right click on player and hit the plus add child node. Go ahead and navigate to node 2D and click on animated sprite. Double clicking on it will now add an animated sprite as a child of the player kinematic. If I hover over it here, we'll hopefully label it as the player kinematic body 2D node. This means that our player node here has a sprite. So let's go ahead and give it an actual image here. Let's go ahead and make new sprite frames. I did so by, again, you won't see this, by the way, unless you actually click on animated sprite. The menu down here that you're seeing is the editor for the specific node. So if I click on player, we'll see that we have some kinematic body 2D variables that we can modify here. If we click on animated sprite, we can see its variables, as well as the variables that it has inherited from its parent objects. But now go ahead and check the frames variable. Click on it, it should be null right now, and create a new sprite frames. Once you've done so, click on it again and hit edit. We're now greeted with the animation frames editing screen at the bottom here. Go ahead and hit this folder in the top left. Navigate over to the Godot Spaceship Shooter folder, then Spaceship, then now the Spaceship. There you go, it's my spaceship. I drew it myself. It's real bad, I know. Don't make fun of me. So, we have the spaceship, but let's add some animation. Go ahead and click the the page button here under animations, and soft double click, or actually, wow, single click, never mind, on the new animation, and let's rename this move left. Now remember this for future reference, because we are actually going to be using these exact names when we're referencing them in the code. And again, let's go ahead and click on the folder here, open the move left folder, hold Control, and left click on both of the images. And ta-da, here they are. I'm going to go ahead and change the animation speed of this to 10 frames a second. Also going to add another animation for moving right. And then I'm going to backtrack, move right folder, and add the images of the spaceship moving to the right. And I'm again going to change the frames per second to 10. So now that we have the animation set up here, let's go ahead and start by adding some wonderful script to our player node here. Now you can think of the script as being just that. For our node, it is the instructions for what the node will actually do, what situations, etc., etc. So let's go ahead and path to where we want to save the script to. I'm going to save it, since it is for the player, for the spaceship, I'm going to save it in the spaceship folder. So I'm going to go to, I'm just going to path over to it. So we're going to find spaceship. Right here's good. And we're going to call it the player script, since the script is for the player. Create. And now you'll notice that we've hopped over from the 2D editing plane to the script editing plane. In the editing plane, we're going to be using the language known as GDScript, at least in general terms, because you could use C++ if you, again, you wanted to change some of the in-engine features here. Don't mind me, I'm just going to be removing some of these pre-made comments for us, because we're a little bit above that, aren't we? If you aren't too familiar with coding, you really just want to use this, or rather you're more focused on the art part of a project, this is a group assignment, go ahead and just copy the first set of highlighted information in the table labeled 1 here, and I'm actually going to, where am I going? Oop, I'm going to open that up so you know which one I'm talking about. If we open up the included documentation, go ahead and copy the first top half right here, and go ahead and paste that. Go ahead and paste that over all of this. But instead, I'm going to go ahead here and start typing this out, and the people who are meant to be working on the programming, or obviously are interested in learning the programming, go ahead and follow along. Now, GDScript is based on Python. The syntax is very similar to Python, although it is not exact. So I'm going to go ahead and start here by giving ourselves a constant variable by using the tag constant. It's a constant, so I'm going to call it in all caps. It's going to be move speed, how quickly our character here will move while we want it to move. I'm going to make that 8. Now, I'm going to be using the ready function. The ready function happens whenever the scene is instanced. Remember that what we're really looking at here is a scene, and the node right here is in the at the top left of the scene, which should actually be its origin point. But this blue bounding box here is the viewport, which is what the player sees, and thus the scene. So whenever the scene is created, and the scene, specifically including the player spaceship, this is executed. So we want to make sure that whatever we want executed in here, we want to keep in mind that this will only happen once, and that's what you want. So what we want here is to first set the operating process here to true. And what the process method function is, it's this. By setting this to true, we are telling the object that, hey, I want you to perform this process, what we're going to write down here, every frame. It's also important to note that for when you're ending if statements or functions, you want to have a colon at the end of them. Again, very just much like Python. If you're following along with the copy and paste, you'll notice that I'm missing a couple of the lines here. Don't worry about those. I promise we'll get back to them. Now, if you're following along in the documentation, go ahead and copy the second part. Go ahead and copy and paste in the second part right up here. So now we're going to declare some variables for our process function here. The first one being the position of our player node. You want to do that? Well, it's quite simple. You just say get pose or get position, which retrieves and returns a vector2. And a vector2 is an object that is essentially, you can think of as formatted as something like this, or more familiar perhaps, like this. It's a set of coordinates, an x and a y. I'll leave that there. That, it seems good for your reference. Okay, now let's go ahead and get the reference that's needed for the animated sprite. I'm going to go ahead and call it spaceship. And in fact, I'm actually going to go over here, click on the animated sprite, click on it again. I'm going to rename it spaceship because that's what it is. It's the sprite, animated sprite for our spaceship. I'm going to go back to the scripting menu, var spaceship. We want to get the location in memory for the spaceship, for the sprite. So we're going to use the method getNode. GetNode, the node spaceship. There it is. This works particularly because the player is the parent object of the spaceship. So getNode is able to say, okay, well, do you happen to have a child node named spaceship? Hey, there it is. Okay, so we're going to get you the memory address and store it in the spaceship variable. It's important to note that variables is a generic type, and or at least by that I mean you don't need to specify that it is an int, double, string, or whatever have you. It's just a variable. I believe that's called dynamic. But anyway, now we're going to start implementing player input here using these variables that we've created. Go ahead and copy and paste the rest of this giant mess over here. The rest of this giant mess over here, it's highlighted green. At least it might be. Depends on if you open it as a PDF or the ODT or whatever file format you chose. Go ahead and copy up to move left to the spaceship set animation. Go ahead and paste that. Right here. So now I'm going to start. Let's start with, of course, move left. We're going to start with an if statement because we want to check if the player is actually pressing the specific button that we're going to map to moving left. Now, how do we do that, you may be asking? Well, it's quite simple. If you remember, I said to remember where exactly the project settings are. If you forgot, it's a little refresher. Top left, scene button, scroll down, project settings. In the top bar here, input map. We're going to make our own input action. You can use the ones that they already have here, but for the purpose of actually showing you guys how it works, let's go ahead and make our own. I'm going to be titling it player underscore move underscore left. And then I hit enter. And I've now made my very own input map. It's so cool, right? Yeah. Go ahead and move over here to the right side of the menu. Go ahead and hit plus. Then hit key. Then press any key that you want to bind to player underscore move underscore left. In this case, I'll go with the A key. I'm going to do that again. And I'm going to hit the left key. I'm going to backspace left and right and make another input map. Again, much of the same, except this time I'm going to hit D. Then I'm going to hit right. There you are. Go ahead and close that window. Return to the script editor. If you manage to make your way to the 2D, just hit script again up here. And now we're going to reference what we just typed in. So now we're going to say, in fact, it already filled in for us. Look at that. Player underscore move underscore left. This is, again, going to check. It's going to ask, A input. The player happen to hit any of the buttons that would pertain to player move left. And if you remember, we binded this to A or the left key. So if the player has pressed A or the left key, this will return true, and therefore the lines of code under the if statement will be executed. And then the colon, and hit enter. You'll notice that auto indents, and you'll also notice that I'm not using curly brackets. That's because of the colon, and because this is based in Python, because it is indented, it is therefore part of the if statement. You do not need to worry about brackets or grouping as long as the indentation is correct. So you will have to indent int properly. So now let's go ahead and set our new position here to be a brand new vector 2, because remember, new position and get position are vector 2s. And we're going to say, well, we'd like you to get the current position of our player, specifically the x coordinate that is located at, and subtract move speed. Now, why subtract, you're probably asking? This is because of the way that the x and y axis coordinate planes work. The x-axis, of course, if you were to add 8, move like right there, that'll be moving to the right. If we subtract, boop, boop, we're moving to the left. The y-axis, however, is inverted, so when we're adding to the y, we're actually going down, and when we're subtracting from the y, we're going back up. Keep that in mind if you decide to use vertical movement for something like a platformer. However, if you are going to use platformer, when we get to collision, I would recommend that you just use the built-in physics engine of the Godot engine, because it is rather robust and makes a lot of sense. It has a lot of utility as well. Back to this. We want to make sure we have our y coordinate. So we're just going to say get the position, and please give us the y value. That's why we have the dot y there as the reference of the position dot y, the y value. Now I'm going to be doing the next comparison twice. This is rather inefficient. However, I'm going to do it for clarity's sake and to make sure that everyone's on the same page. I don't want to do anything too fancy to confuse people. So we're now going to check if the viewport rectangle. Now what's the viewport rectangle? Now as I mentioned already, the bounding box for the viewport is this blue box. The viewport is exactly what the player sees. By saying get viewpoint rect, I am asking to get the rectangle object of the viewport, which is essentially just like the x and y coordinate and the width and the height, some other various things. But essentially, what you can do with the rectangle to the object is you can access the rectangle 2D methods, which again, if I can find it, there's rect2. You can access the rect2D methods in the API. Specifically, we're going to be using hasPoint. So we're going to say dot hasPoint new position. And what this is asking is, within the rectangle bounds of this viewpoint, do you have the point or the position where we want to move the spaceship to? Because remember, we set new position minus x. So we've essentially said, if I move this spaceship over here, and now we're asking, is that out of the viewport? So do you contain, oh, sorry, we're actually asking, do you have that point in the viewport? And if it is in the viewport, we're going to set the position of the player to the new position. And that's it. But we also need to change the animation. So we're going to use the spaceship reference that we made to the spaceship node right here. So does the spaceship animated sprite, is its current animation move left? If you recall, if we go back to the animated spaceship, I click on the frames and hit edit, that's what we named it, move left. So if it is move left, or rather, excuse me, if it isn't move left, I'm just going to set the animation to move left. Just like that. And that's pretty much all of the code, all of the code that pertains to moving left. Moving right is again much of the same. In fact, so much so the same. I'm just going to copy paste it. Go ahead and change this to right. And again, if we go back to scene, project settings, input map, remember we named this player underscore move underscore right. And because we're moving in the right direction, we have to add the move speed instead. And we want to check if the animation is move right. And that's more or less all that you need for the general animations and such, for at least for key bindings and all of that. But we also want to make sure, because I did forget, that in the animated sprite, specifically now spaceship, in the animated sprite settings, we want to hit playing. We want to check that as on so that the animation is actually playing and not just stagnant. Otherwise, even though we'll switch to the, even though we will switch over from this image to this image, we won't actually play the whole the whole animation. We'll just stick on the single image here because it's not playing. But right, just make sure that you have playing on. So I go back to the script here, but now we're also realizing that well, hey, wait a minute, we sort of need to make sure that what if the spaceship isn't moving? It shouldn't be tilted, and at least in this case, the way I drew it, the engine shouldn't be flashing. So we also want to have a default, which means also that we also need a default action. For example, what if the player is pressing both left and right? Does that mean that the spaceship should be staying still, or should it be default to one direction? It's up to you, but in this case, to also demonstrate how if-else statements work, we're going to make it default to left if both left and right are being pressed. And I would like to also point out that else if is elif. It is not It is not else if. It's not else if. It's elif. If you say else if like this, it will not work. Use elif. That's why it's a distinction. The actual else is just else. And again, even if this doesn't have a condition, you still need a semicolon there. I'm just going to comment this as the default animation here. And then by default, obviously, if nothing's being pressed, it doesn't need to be moved. And we need to make sure that the animation, set animation, oops, sorry, spaceship.set animation to default. Like that. So we've gone ahead and mapped out the input mapping and hopefully movement for our character, but we haven't really saved anything yet. The script needs to be saved. Go ahead in the script editor, hit File, Save that up, and I'll go back to 2D to look at the scene. Control S, or you can go over to Scene, Save Scene. Again, this is the scene for the player, so I'm going to navigate to the spaceship folder, hit Save. And if we want to check on that, we can actually just go over to the file browser here in the top left, right under File System, hit Spaceship, here's the script we made, and here's the scene. So now, we want to actually play this, don't we? But I'd rather not have this be the actual player, because this is a scene for the spaceship. We want a scene for the game. We want a scene for menus and stuff. So let's backtrack to the res folder that contains the icon for the Godot engine, and we're going to create a new scene. To do this, hit Scene, New Scene. Remember that scenes can be separate rooms. They can be stages for you to set up your menu screen, different levels. You can have a level be a separate scene in and of itself with a viewport that moves along with the player or something. Or the scene can contain specific objects like we're doing here. And in this way, we can instance them in this scene. So in fact, the first thing that I'm going to do is all scenes by default inherit start with a viewport as the parent. So I'm first going to make a generic node and call it the container, because in this game area, this would be where our game is. It needs to be able to inherit from whatever object it is, and node is the most generic type that we have access to. But remember that this node does inherit from an invisible viewport, sort of like how all objects in Java inherit from object. So now, I'm going to click on this, and we want to instance the scene we had before, the player scene. Go ahead and click this link-looking button, and this will instance a scene. Go ahead and navigate to wherever we saved that in. We saved it in Spaceship, and here it is. So now we have our player object in here, in our new game area. Let's go ahead and drag him to where we want to be. Or rather, you can also click on the player, scroll down to no 2D, position, and you can alter these manually. I'm just gonna flatten these out, I guess, I don't know. If you need to set it to a specific position for whatever reason, you can go ahead and do that there. Alright, so let's play, let's do it. Whoa, whoa, what's this? The scene's never been saved. That's right. You do that, but we also need to do something else aside from just saving it. I'm going to save it in the res folder. Let me call this game. Whoops. Hello. I'm going to call this the game area. Oop. Let's hit play. Woo! But we forgot something. We didn't set a scene for the project to start in. So the project wants to know, hey, so where am I going to start the game? Am I going to start it here in the player scene, or do you want to start it here? Or we want to start it here. So we're going to hit Scene, Project Settings, go back to General if you aren't already there, and Application, hit Main Scene. I'm going to hit the folder, File, right there. Hitting play will also bring up the same dialog for you automatically, but I just want to show you how to do it manually. Hit play. Okay, looking good so far. And hey, look at that. You can't see it, but I'm pressing left and right, and it's moving. I'm pressing A and D, and it's moving, and the engines are flashing. Woo! Fancy that. So now we have a spaceship set up. Let's make it shoot stuff. Let's go ahead and make a brand new scene. Let's go ahead and add another node. And again, we're going to go with the kinematic body 2D here. Just going to navigate to that. All right. I'm going to be naming this friendly projectile. Oopsie daisy, sorry, projectile. I'm going to be adding a brand new sprite to it as well. This one's not animated, so we're just going to use a regular one. And we're going to rename it friendly laser. We're now going to navigate over down here to texture, load, Godot space shooter, laser, and we're going to pick the friendly one. Isn't this a beautiful looking laser? Look at that. It's a blue rectangle. That's all it is. It's a blue rectangle. Look at it. Alright, so there's our laser. That's all well and good. Let's go ahead and give it some instructions, shall we? Click on the friendly projectile. Add script. Again, I'm going to path over to, whoops, it is. I'm going to path over to the laser. That's the back button, by the way. I'm going to call this the friendly projectile script. And create. Now, if you're following along in the dock, I'm going to skip ahead here. Ignore the pink stuff for now. I'm going to go down to here. Go ahead and copy the first half right there. I'm going to start with the class variables. We start with for our projectile speed. I'm going to make that 400. We're also going to have a direction of movement. This is going to be the shoot direction, and this is going to be vector 2. Because remember, vectors both have speed and direction, but yeah, it's a physics term, don't worry about it. So we're going to set the position of our bullet here. I'm going to have it be a default of 100, 100. Now this is mainly for testing purposes. If you want to see the vector at a specific location, then you can go ahead and use that there. But anyway, we're now going to make our own function here, and we're going to give it the following method variables here: position and direction. Again, I would like to clarify that this is mainly just for testing purposes, so that if fire isn't called, the projectile will appear at 100, 100. That's more or less what that's saying. The way that the fire works is we're going to map the variable we assigned, shoot direction, vector 2, to direction dot normalized. And what that's just going to do is it's going to take this direction here, this 2D vector, it's going to normalize it, make it a unit vector of 1, and then it's going to grab the direction of it. I should also mention, by the way, that we are moving on to this part, right there. The part in blue, hello. Now I'm going to set the position of the bullet to wherever whoever is firing it, whoever calls the fire method has to specify a position from where the bullet will be fired. And then we're going to begin the fixed process of this. Similarly to the player script, set process, true. Fixed process is just another process that you can use here. And yeah, so now let's go ahead and define what exactly is going to happen in the fixed process. Again, make sure you're copying this exactly as I am, because the fixed process, we want to override the method, not overload it. Okay. So now we're going to use a built-in function of the kinematic body 2D, and if we look that up in the API, okay, it's just there, sure. We have a, where is it? Right here, move method. We just we're just using it. Again, reference the API whenever you're unsure about what methods are available to you in a specific node. So this specific method takes in the 2D vector. So what we're going to do is we're going to take the direction in which we want the our bullet projectile here to shoot. Make it move by projectile speed over the delta, the change of time since the last frame. So essentially we're shooting it in whatever direction at this speed, and this is just to specify over what length of time we're checking here. In this case it'll be rather small, which is why the projectile speed has to be so high here. Now if you're following along on the dock again, we're going to skip this last part as this has to do with collision, and we'll get to that later. But now we're going to save this particular script. I didn't save. Huh? Oh, it did. Sorry, it did save. But we're going to go back to player, and now we're going to talk about shooting. Go back up in the dock, copy this pink stuff, put it in right at the bottom here. Again, you want to make sure that your that functions are called without any indentation, otherwise it will be part of the other method and you'll get an error. So we're going to say function underscore import event, and this is for shooting. Now if you aren't copy and pasting here, you're going to have to scroll back up with me here. We're going to go back to the ready, and we're going to do set process input. We're also going to make that true, because we also want this process to occur whenever there's input. Now the reason why we're doing it in the input event is because if we do it up here, what this checks for is it checks every single time we're holding right and left. In this case, I only want the player to be able to shoot once per click, so they essentially have to mash the key to shoot. If you don't want that, if you like a continuous laser while the player is holding up or whatever key you bind it to, then you can put it in here. But in this case, I only want it to shoot once, so we're going to put it in here. Once per click. So we need to load in our projectile for shooting, and we're going to do this before we actually do a check, just to make sure that it is available for us. Again, remember, Godot is based in C++, so we need to preload memory. So we're just going to use the method preload, and unfortunately, we have to path all the way to wherever the specific projectile scene is, and I just realized I didn't save the actual projectile scene yet. And we need to do that. So so I backtracked over to the projectile scene. I went to the 2D editor. You can see the projectile there. Now I just hit Control S, so I'm now saving it. Path to laser. Finally, projectile scene. Done. Go back to the script, and we have to path to it. You can actually just look at the path over here in the top left where it has the file system. So we're going to see, let's see, res : / Godot space. Wow, that was redundant. Space shooter / laser / finally projectile.tscn and string closing parenthesis. I'm just going to double check. Finally, projectile.tscn. I could have spelled that wrong. Again, a lot of errors that you get very confused by. They could just be spelling errors, so don't get too frustrated. Gonna have an if statement here. So now, if the specific event of the input is finding that our player has moved, that has done player shoot, and we're gonna have to define this again. So we're gonna go back to scene, project settings, input map. I'm gonna make player shoot, and I'm going to let the player shoot by pressing the W key, the up key, or the spacebar. So let the player shoot. We're going to now create the variable laser, and we're going to instance the preloaded scene that we made. So we're going to create a copy of it. I'm going to make it an instance. We are now going to get the parent of whatever the player's parent, and we're going to add the laser. Whoops, we're going to add the laser as a child. Wow. Now, I would like to point out here, because of the way we have our game area scene set up here in the hierarchy, the parent of the player will actually be the container. So, we're actually adding the friendly projectile as a child of the container in the game area sense, which is why this script particularly works. And now remember, we do have to fire this laser, otherwise it will appear at 100, 100. Laser fire, whoopsie daisy. Get position, because remember, if we go over to our friendly projectile thing, friendly projectile script, we define the fire method as needing a position and direction. So we're going to give it a position, our position, the position of the ship, and we're going to make it fire straight up, which should be 0, -1, and done. Now, hopefully, assuming I didn't do anything right, or excuse me, do anything wrong, we should be able to hit play here, and we'll get to see our spaceship going ahead and doing that now. And we found an error. Let's see. This is located in the friendly projectile. I seem to have misspelled something, if I'm not mistaken. Let's see. Identifier not found position. And, true to my word, I did misspell position. Let's go ahead and try again. Okay, all seems good. And we hit up. Yay, look at that. We have a laser. Woo! We're shooting. We're mashing the thing. And again, you don't have to, you can just ignore this, by the way, don't worry about it. You can, if you don't want the player to have to press up every time he wants to shoot, then you can go ahead and just put this part up here, and then change event to input, and it will detect every single time. There's also another method called isActionReleased, if you want to do something when the key is released instead. So this is all well and good, I suppose. We have a spaceship, we're shooting stuff, but let's actually shoot something, huh? So let's go ahead and give our spaceship friend an enemy. That's not really a good thing, actually, now I think about it, but you know, let's give him an enemy anyway. Alright, go ahead and make a new scene, as we usually do. To the editor, and again, we're going to make a kinematic body. I usually prefer to use kinematic bodies for a space shooter, because you can use collisions on them, and they aren't affected by the actual physics engine in most cases. Actually, I think in all cases. But so if you want to use the physics engine, you'd probably want to use something like a rigid body. Static bodies are actually for platforms and such. Again, keep that in mind if you want to do a platformer or something. So go ahead and double click on this and rename this enemy. And we're going to add a sprite to it on the child node. Sprite. Again, was frankly not feeling animation. It's not my strong suit. So there's our image of our enemy. It's a cute little UFO. I think I did a good job. Anyway. Tab the UFO. And as we usually do, let's go ahead and add the script. Navigate over to enemy. Change the name of the script. Delete enemy script. Create. Alright, so in the enemy script, go ahead, and if you're following along with the documentation, we're going to go ahead and copy the yellow highlighted section up here. Whole thing, and paste it in. Let's go ahead and start with our class variables as we usually do. I'm going to make a variable called ex, or x. It's a pun, get it? Haha, because it sounds like x when you actually say it. I'm going to make a new variable called speed. This will be how quickly our UFO and friend or enemy moves. And we're going to give it what is a constant move range, although I'm calling it a variable because to make it a constant, I have to give it a constant. I'm not going to do that. I'm going to instead use randf, which will make a random float. Multiply that by 300. and add 100. Whoops, it is, and add 100. So what this will do is it will create a random number, random float rather, from the range of 100 to 400. Actually, I think it'll be like 399.999. You get the point. So those are our instance variables, and again we're going to start with the ready method. All right. So let's go ahead and start here with enemy. We're going to define this this function later on, so don't worry too much about it. We're going to do enemy set position get position. I know, a little redundant, but just bear with me for it. We're going to say set process true, and then we're going to skip that print self statement there on the dock because that is for debug purposes if you need it. The print self statement actually just prints out the node memory location for you for ease of access. You'll also notice that I skipped the get node timer start because we haven't done that yet. Give me a little bit. So let's go ahead and make the enemy set position function here. It's going to take new position. Now what we're going to do is we're going to set position to new position. This is just in case that if any other object other than the enemy wants to change the position of the enemy, for example, let's say we want to add a script to the game area itself to set the enemy somewhere. Go to the script menu. If we want the game area to be able to set the enemy somewhere, then it has the option to with the specific function. And then we're going to reset x to new position.x. Now what is x for? The general idea of what the AI is going to do is going to be very simple. It's really just going to move back and forth. X will be the origin point. X plus move range will be the maximum move distance to the right. We're going to the document again. We're going to go ahead and start doing this part right now. So go ahead and copy and paste that in. Again, you should be familiar with this already as we did it in both player and friendly projectile. Oh no, we didn't read the fixed process for that one. Never mind. We did do it for player though, so we should know what that is. And now we're going to create a new position, specifically cur x, which is just going to be the x value of our current position, the current x value. So now, if our current x value happens to be less than x, as in we're about to go past our, or we've already gone past our original starting point, or our current x is greater than our maximum, which would again be x plus the move range, excuse me, then we're going to flip the speed. So now, when we actually update the speed, I'm going to show you how we're going to do that. We're going to set the position to a brand new vector 2, so we're going to use the constructor for vector 2. The current x plus speed with our current position y, because that is not changing. There we go. Yeah, there we go. So, again, because we're adding speed here, we're going to add a 4, but once we get past our maximum move range, it's actually going to flip, so we're going to add a negative number, so it's going to subtract, and therefore going to go to the left. Simple AI, nothing too complicated. And then again, we're going to ignore if is colliding there at the bottom. It's fine if you have that in there from the doc right here, these two lines, but again, that's just for debugging purposes for you to show you what's exactly going on there. Okay, so now we have our enemy moving back and forth there. Let's go ahead and add him to the main scene. Right here. Gonna go ahead and click on the container. Add instance. And hey, guess what I didn't do? I didn't save the scene. So I'm gonna go back to the enemy file again. I want to stay organized. Save it there. Go back to game area, container, add an instance of a scene, and there we go. Pop. Like, you can put it wherever, you know, it doesn't really matter. Okay, so let's see how this behaves. Wow, it's moving back and forth. And we can't kill it. It's invincible. Okay. So now let's make it invincible, I suppose. Let's go over and Actually, strike that. Let's give it a laser first. Let's make it fight back before we start talking about collisions. That would probably make more sense, admittedly. So now we're going to make the enemy projectile. Let's go ahead and make a new scene here. Gonna do much of the same as we've always done. Kinematic body 2D. We're going to rename this enemy projectile. And you're going to notice a little bit of redundancy here. And redundancy is the enemy of coders, of all programmers. To make this simple, I'm not going to be reusing the code that we did for Friendly Projectile simply because, again, I want to make this simple. But if you're so inclined to, why am I doing this? AnimatedSprite. If you're so inclined to, you do not have to. You can actually reuse the. I'm sure you could figure out a way to reuse Friendly Projectile. But in the meantime, let's keep things simple. Go ahead and set up enemy laser here. And set up its sprite. Right there. Okay, so now we're going to, again, start with a script. But it's going to be very similar, in fact, almost identical to our friendly projectile. Sorry. I was checking something. This is the enemy, sorry. I'm going to enemy projectile. Right there. Create it. Here it is. I'm actually going to follow along with the documentation as well because, again, this is much of the same. You can go ahead and just copy the top half there. Ignore the collision code there. As you can see, it's much of the same. However, the only main difference right now is that I've changed the function speed there, so that it moves a little bit slower. Also appears that the tabs here didn't register. It's not a huge deal, but just to make sure. I did thought I see some. Yeah, I did. I thought I did see something different. I'm pretty sure that's bad grammar, but oh well. Let's go ahead and save this script. Thank you. And now let's go ahead and make our enemy shoot at us. If you're looking at the documentation, you'll notice that we have a particular method called onTimerTimeout. What that means is we're actually going to need to add a timer to our enemy. Go back to the 2D editor, just for some visual purposes here, and we're going to add a node to our enemy, and it's going to be a timer. Now, timers allow me to show you, excuse me, timers allow me to show you some of the cool properties that come with, come along with it, and some of the cool functionalities that come along with the Godot engine, specifically signals. Now, I'm going to set the wait time to 1, so every 1 second, this timer will go off. And if you check off one shot, then a timer will only happen once. So if one shot is disabled, every 10 seconds, this timer will emit the signal timeout. If we set to one shot, every after 10 seconds passes, it will emit timeout once. I'm going to set this back to 1 because I think 10 seconds between the UFO shooting is pretty long. I'm going to disable one shot to keep shooting. Now what we're going to do is we're going to double click on the timeout signal, and we're going to select the node that we want to have timer send that signal to, which is enemy in this case. And there we go. It actually automatically filled it for us, like I think the compiler should. You may reference the doc for copy and pasting the rest of the method in, but again, let's walk through it. I'm going to make a project actually this is almost identical to the to making our friendly player shoot. However, instead of needing an input, we just need to wait for the timer. So again, I'm just going to be looking at the top left here to get our path. Godot space shooter laser enemy projectile dot tsn. It's tsn? TS? Yeah, tsn. Cool. Again, we're going to instance this. as a laser. And it's this thing again, creating a... Oh, what did I do wrong here? It can't reload the resource of the path. What? Oh, I didn't save it. My bad. My bad. Let me save the scene. A new projectile. There we go. Go back to script. A new projectile. Oh, nope, sorry. Enemy. It still can't preload it. Godot space shooter laser enemy projectile. Did I spell it wrong? Did I spell the scene wrong? Enemy projectile. Let's see if we continue here and see if it will still give us that error there. So now again we're going to do again much of the same. Add the laser as a child of the container in the game area. Oopsie daisy. The child there. Going to be passing it laser again, which is the reference to the object, and yes, the error did disappear, so it refreshed. And again, we have to make sure that we actually fire the laser, otherwise it will be stuck at position 100, 100. Fire it from our position, and instead of firing it down, we're going to be firing it up. Sorry, instead of firing it down or up, we're going to fire it down. And there we go. All right. You'll also notice here that after we got to mention this, after we set the signal there, you can see a little plug there. That means that it is sending an output or a signal to something, in this case enemy. You'll also notice that as I'm updating all of these, I don't have to like remove this enemy from the scene and then add it back in. It automatically refreshes because it's instancing this scene and we're editing it. Doesn't appear to be shooting. Let's find out why. Oh, you know why? Because I forgot to start the timer. And we can do that. And we're supposed to be doing that in the ready function. So to do that, we're going to get the location of the node, which is right here. Get node.timer dot the function start. Again, you may reference the API to find that the start method right there. You can see I've already been here. Yeah. Go ahead and play it now, and we have a null instance because I didn't rename this to lowercase timer. And there we go. But you know there's still no hitboxes. Why are there no hitboxes? Why are you being mean to me? It's okay. That's because, remember, I asked you to ignore hit detection for the projectiles, and now we're going to add those in. So now we're going to move on to making sure that there's collision detection in our game. The first and most important thing that you need to recognize is that we need to bound a collision box or collision shape or collision vector or collision whatever you want to our object. We're going to add this as a node, of course, because everything in the engine is a node. Node 2D. Collision object. Sorry. It should be here. Here it is. Collision shape 2D and collision polygon 2D. It is important to note that only the collision shapes can only be added to physics-enabled objects. Kinematic body 2D is technically physics-enabled, but again, it doesn't really follow general physics rules, or at least in the physics rules as in the engine. Go ahead and click on the node here. If you're on the node signals like I am, go ahead and hit inspector so we can view its instance variables and give it a shape. I'm feeling round today. I don't know about you. And we're going to scale it up to 4 just because 4 fits it. And there we go. We now have a collision shape for our spaceship. I'm just gonna leave the collision shape too. Why not? Let's go over the enemy. Give it much of the same. And voila. Do the same thing for projectile. Right there. Pop. Rectangle. Pop. I mean, just do 2. Perfect. Actually, it's a little bit bigger. Better. same thing with the enemy projectile. Not super exciting, I know, nothing super unusual either. And just change that to 1.5 because it seemed to work for the other one. Cool. So now we have our collision boxes. Let's see what happens when we just go ahead and run it. And like I said, the collision boxes don't really behave like they're enabled by physics, but you'll notice that they're actually colliding here and getting stuck. And that's because, well, they have a hitbox. Obviously they're going to collide and get stuck. Bop. Just kind of balanced it right here. Okay. This is kind of a fun game. I don't know, who knows, maybe you could do like a stack-up game. Basically it's enabled Tetris. I think that's where they game. I believe it's called Tricky Towers, something like that. Anyway, that's fun. You can play with that. Honestly, it's, I'm not gonna lie, it's pretty entertaining, isn't it? But now, we want to disable that from happening because we don't want projectiles, you know, touching and colliding like that. I don't think that's how lasers work. At least that's not how it works in StarCraft or Star Trek or whatever you want to draw your laser rules from. We're going to set the property trigger here to true. So as it says, set whether this shape is a trigger. A trigger shape detects collision but is otherwise unaffected by physics, as in it won't bump into things. Sure enough. Lasers. Okay. There. Problem solved. But if the ships collide, then they will... Obviously the ships can't actually move toward each other. But you could totally do that. And if you wanted to do that, remember, just go to project settings, input map, player move up, and you can just bind it to keys. And then if I were to open the script for the player, you would just change, instead of having this, you would just modify the Y over here. Back to business. Excuse me. If we want to go over to, I believe we want to check for collision first. I guess suppose in the enemy object, I think this would be, the enemy projectile would be simpler. We want to give it something else because, unfortunately, collisions between kinematic bodies, where one is a trigger, doesn't actually register properly. However, we can use something else instead as a child object of our kinematic body 2D. In this case, we're going to be using something that is under collision object 2D and area 2D. And the way we can do this is we're going to make a child object of a child object. That's right, we're going to, there we go, we're going to child object inception. So this kinematic body 2D, which is the enemy projectile, has a child node called area 2D, which has its own shape. So right now, the enemy projectile actually doesn't have any shape to it, but the collision shape does. But the area 2D that is part of the enemy projectile does have a collision shape. Now what we can do with that is the area 2D has its own signals. Specifically, we're going to be using body enter. Hopefully the body of this projectile is ready, am I right? Go ahead and click that and connect it to the enemy projectile script. And here we have on area body enter 2D. Backspace to stuff it pre-fills in for you. If you're referencing the doc again, check out number 4 and right here, the very bottom. So now we're going to be doing some hit detection, but we want to make sure that we're actually removing the right objects. If the body that has entered the 2D area, which in our case is that rectangle, if whatever object that enters that rectangle is in the group friendly, what's that mean? Ooh, it's a new word. Body queue free. Again, it's based in C++, so we need to free up that memory, and that equates to deleting it off of the face of the planet. So we're going to essentially tell whatever the laser collides with to destroy itself, and we're also going to destroy the laser. You don't necessarily have to do that part, but you know, I'm just going to do it. Body is in group friendly. So now, what's the these groups? Well, they're right next to signals actually, and there are unique identifiers that you can add so that you can sort of differentiate factions or whatever else you may think you may need groups for. Let's go over here to player, and let's tag him a friendly. Let's also tag the friendly projectile as friendly. This way, when the player spawns a laser, the player doesn't kill itself with its own laser. But we'll get to the friendly projectile hit detection in a second. Oopsie daisy. Where did I? Yep, I missed the colon. I do that sometimes. There we go. So what should happen is, so I ran into a bug when I actually went to run it, which is why there's that weird cut there, where I actually wasn't getting hit, and I realized the reason was because I accidentally set the collision shape to be in the group friendly. The reason why this doesn't work is you actually want the player object to be in the group friendly, not the collision shape, because the player object actually contains the collision shape. So therefore, it makes more sense for this one to be in the group and not just the collision shape. And I believe I probably did, yeah, I did the exact same thing for the friendly projectile. So we're going to want to do that. And while we're at it, let's go ahead and make sure that we do the same thing for this, except I'm going to put the UFO and the red projectile into the enemy group. Let's go ahead and hit play. And now our ship dies when it gets hit. But what also dies when it gets hit are the lasers. So now we're going to add the player object. I'm going to double check and make sure I'm clicking on the on this object here. We want this to be part of ship. We want this enemy UFO to be part of ship. Now that they are both part of ship, we want to edit the script to also recognize that the object that is colliding with is also a ship. That is not how you spell ship. Yeah, I thought I was missing a parenthesis. Hit run, and lo and behold, lasers don't collide, and we still die when we get shot. Perfect. So now that the enemy can kill us, let's make sure we can kill the enemy. Again, we're going to have to add the area 2D to this, and then put the collision shape underneath it, like so. That noise you heard was my Alexa hearing me, and I wish it would stop. Thank you. So now we're going to go over, sorry about that. So now we're going to go over to the script again. Oh, sorry, we're going to go back to the area 2D node, and we're going to make sure that it gets that the signal of body enter goes to the friendly projectile. That's an error. We're going to have much of the same in terms of the if statement. If whatever we're hitting is an enemy, and is in the group of ship, then you can go ahead, whoops, easy. Then you can go ahead and delete the thing that's hitting, as well as delete this projectile. But let's make it a little bit more interesting. I'm going to define a position here, and I'm going to make it random. I'm going to make it random within the range of, I don't know. Let's go with, say that. What is that? That's 100, between 100 to 600 and 50 to 250. By the way, I believe we're right here. Right here. Number 3, the bottom section, the last bit of code here. Times 50. That's just a random position that we're going to make. Let's go ahead and preload the enemy ship here. So again, I'm just going to look over to the file management over there in the top left. Go space show dart enemy.tscn. Whoops. Boom. We're going to once more instance this ship as we did with the projectiles. And then we're going to set the position, whoops daisy, we're going to set the position of the object to the random position that we just made. And lastly, we are going to add this, this ship. We're going to add this ship to the game area. So it's going to be added to that container. Just like we did with the projectiles, except now we just gave the ship a random location. When we hit play, sure enough, It dies and it makes a new one. It dies and makes a new one. I died, and we lose the game. And that's pretty much it. Those are all the code excerpts that are located in this Word document, so I can go ahead and close it. But that's it for a general overview of how the Godot engine sort of operates here. But as you can tell, the game is pretty incomplete. There were some parts missing, but that wasn't the point. That was the idea was just to give you an idea of how the whole engine works here. Maybe, perhaps, if you wanted to, oh, I don't know, make this a little bit more interesting here. Maybe add a score counter. Go to the inspector, just set the text to score. Let's do that. Right? There's a score. Obviously, there's not much else. You said score. Maybe we could. I'm gonna do this like on the fly, right? Let's attach a script here. Game it, sure. Works for me. Let's, oh, I don't know, set process true function process delta, and then let's basically these lines. Now particularly the label, the label node has its own set of functions, again defined in the API, as I keep mentioning. I'm just gonna make that lowercase on. But maybe your game area has a score, right? And maybe with this label, you can set label dot, I believe it's set text. Don't quote me on that. I'm gonna find out if I'm right. Do some concatenation here. Plus string of score for, excuse me. My mistaken use score is equal to 0. Let's go like that. See how that works, huh? Oh, yeah, well, score is 0. Score is still 0. And that's apparent, and that's evidently the problem that we have right now. So let's see. How do they update the score? I don't know. Would it be, I believe what we're looking for would be some way to access the container, then get to its label, then update the score. Update the score variable, which is somewhere, which is there. So how do we do that? Well, perhaps, where if I can find the script, we want to do something like this. Get parent update score 1. So I'm now going to obviously make, I just made that function out of thin air, so we're gonna have to kind of make that. There we go. That's not how you spell function. Okay, so let's see. I want to make that score plus equals val, like that. Let's see how that works. Well, not gonna be able to test it if I die immediately. Hey, would you look at that? It worked. I just got a double kill. Yeah. So again, okay, so that was, I think, relatively simple change, but now there's an objective. Now it can be a little bit competitive, right? Maybe you want to add some more enemies. Maybe you want to explore some of the other objects, some of the other nodes that are available to you in the Godot engine. Hopefully I've given you a good overview of how to use all of the tools, and that random and impromptu thing, I wasn't actually, I was originally just going to put that out as a challenge, maybe try and add a score system, but I did it for you. Maybe add a new enemy. Let's make that the challenge, add a new enemy. Let's do that instead. But now let's say you're done. Let's say this is the final product. Let's go ahead and make it a game. Let's make it an executable. How do you do that? If you recall, at the very beginning of the tutorial, you should have already downloaded the export templates. And it should also still be in your downloads folder. You need those in order to export your game. In order to do this, you're going to go to the top right here, up in Settings, Import, Export Templates. You're just going to navigate to wherever it is. In my case, it's in Downloads. I already did it. But navigate to where it is, double click on it, and yeah, I'll do that now, fine. Yeah. Back up here. Downloads, and there it is. Just click on it, you double click on it, import everything. I've already done that, and you go over. Once you're done with that, go to Export, Windows Desktop, slip all these variables. Android's a little bit weird. Exporting all the other ones are a little bit strange, but anyway, go ahead and make your Windows executable. Hit Export. I'm gonna find the place to save it, and I'm just gonna warn you right now in advance. If you try and do it in the folder, it doesn't want you doing it in the project folder. So just like backup one. The projects, I think they should be fine. Nope, doesn't want to do it. Fine, we'll back up to my general programming folder. Fine. There it goes. That was fast because obviously this wasn't exactly a super robust game. Those are all the recordings. Don't ignore that. By ignore that, I mean do ignore that. Go to programming, and there it is. Look at our fantastic game. It's amazing. And there you have it. I hope you found this tutorial helpful in your endeavors as a programmer. Again, this is meant to be comprehensive. This is also meant to be super in-depth or anything. A couple of the other physics-enabled nodes, such as I mentioned them before. Static body 2D will be helpful for platformers. Again, it's meant to be static, as in not moving. So if you want to have, let's say, platforms or something, you want to set those as static body 2Ds. They will be solid. Then you want to have the player be a kinematic body 2D, which will obviously move left and right. And you press the up, you can sort of give it a upward momentum. And again, if you need to change anything for the specific project, let's say the physics, it's all located up here by scene project settings. You can change physics, you can change gravity, you can change render settings. I believe you can change full screen in application. It's somewhere. It's right here in display. Of course it is. But yeah, I hope you enjoyed it. Hope you had a good day, and best of luck in your efforts in the Godot engine.